Hello kids, let us see our science subject chapter 14 elements, compound and mixture. Now state of matter, that is solid, liquid and gas. Properties of matter. What are they? You can see the states of matter, the magnetism, conductors and insulators, relatively density and solubility. Let us see further. Changing state. That is, water can be boiled as well as freeze. When you will boil, it will become steam, that is gas, and when you will freeze, it will become solid, that is ice. These are what? Changing state. Now, states of matter. Solid, it can be melt or it can be freeze. Liquid, vaporize, condensation. Now, what is matter? Anything that has mass and occupies space is called matter. It can be in solid, liquid and gas state. We can find this matter in any of the state and it has mass in it. Let us see further. Few examples. Pencil, apple, these all are what? Examples of matter. For example, over here, the perfume bottle. When you spray, you will see what? It is in gaseous state. You can smell it. Now, next comes solid state, chalk, the color, the perfume bottle, etc. What is substance? The properties of matter depends on its makeup. Some types of matter are substances and some are not. A substance is a single kind of matter that is pure. It always have a specific composition and a specific set of properties. You can see the example. Example is salt. No matter where it comes from, seawater or a salt mine, it always has the same composition and properties. Now, let us see the next one. A mixture is a substance made by combining two or more different materials in such a way that no chemical reaction occurs. It can be colors, it can be liquids. What are mixture? Let us see. It is an impure substance made up of two or more elements physically combined together. Can be broken down by physical means. No chemical changes take place. Substance held together by physical forces. Has no formula. The properties of an element in a mixture remain same. Now, mixture form when two or more substances combine, keep their physical properties, can be separated by their physical properties and do not form a new substance. Let us see about atom. All substances are made of atoms. Water. What are the atoms in it? Hydrogen and oxygen atoms. Plastic, carbon and hydrogen atoms. Plants, carbon, nitrogen, hydrogen, these all are what? Atoms. Now over here in this picture, you can see the gas, that is gaseous state. Over here also, you spray the water. This is what? Liquid form. And when you steam it, again you will find it in gaseous state, and when you will cover it with a lid, you will see the water vapor. What are elements? It is a substance made up of only one kind of atom. Cannot be broken down into simple substances by physical or chemical means. Have same atomic number. 118 elements are known and are represented by symbols. Now, what are those symbols? We can see further in the chapter or in the next chapter. Next is what? About elements. Element consists of unique type of atoms. Element cannot be further broken into simple substance by any chemical or physical means. Elements are building blocks of matter. It has chemical symbol, 1 or 2 letters. Elements. There are about 180 elements that are made up of just one type of atom. These are what elements? You can see the picture. Helium, carbon and copper. They are what? Examples of elements. What is a molecule? A molecule is an electrically neutral group of atoms joined together by chemical bonds. A molecule may consist of 2 atoms of the same element or many atoms of different elements. You can see the example: oxygen, methane, caffeine, DNA. These are what? Molecules. Now, symbols and elements. I did say you that we will be seeing later in the lesson. These are what? Symbols. H stands for hydrogen, C for carbon, and the examples are goes on. Non-metals. A non-metal is a material that is dull, softer. It mostly lacks metallic attributes. Physically, non-metals tend to be highly volatile. Properties of non-metals: they are brittle, they break easily, they are ductile and malleable. Now, the metal versus non-metal. Light that strikes metals is reflected in one direction, like a mirror. Light that strikes non-metal is reflected in many directions. This metal looks shiny, they are dull, and it is lustrous, but they lack with the luster. Non-metals. Let us see what is an alloy. An alloy is a mixture or metallic solid solution composed of 2 or more elements. Alloys usually have different properties from those of the component. Metalloids. Physical properties more like those of metals, but chemical reactivity is more like that of non-metals. Many atomic properties are intermediate between those of metals and of non-metals. Method of distillation. Take some salt water in a round bottom flask. Arrange the apparatus as shown in the figure. Start heating the liquid in the flask placed on the wire gauze. Observe the conical flask. Slowly, droplets of water start falling into it. Where did these drops come from? The salt water in the round bottom flask boils on heating. The water in it vaporizes. When the vapor passes through the inclined tube, it gets cooled due to the surrounding cold water and condensed to form water. Thus, the drops falling into the conical flask are of the water from the salt solution in the round bottom flask. Salt remains behind at the bottom of the round bottom flask when all the water has collected in the conical flask. This method is called distillation. Distillation is also used for purification of impure liquids. Method of separation using separating funnel. Procedure. Pour a mixture of kerosene and water into a separating funnel with its stopcock closed. Close the stopper. Fix the separating funnel firmly on a stand. Leave the mixture in the funnel undisturbed for a while. Water will remain below and kerosene will float on it. Now, without shaking the funnel, remove the stopper. Open the stopcock to collect the water on the bottom of the funnel in a beaker. Close the stopcock when all the water is collected into the beaker. Now, kerosene and water are separated. Method of centrifugation. Turbid water, ink, milk, buttermilk, blood are mixture of liquids and insoluble solids. When turbid water is kept undisturbed for a while, the soil particles in it slowly settle to the bottom. The particles of milk or ink, however, do not settle even on being left undisturbed. This is because the particles of the solids in such mixture, being very tiny and light, remains evenly disturbed in the liquid. These particles cannot be separated from the liquid even by methods like filtration or settling. In the laboratory, a centrifugal machine is used to separate solids from a mixture of a liquid and solid. It consists of a disc which rotates like a fan on great speed. There is provision to attach test tubes on the rim of this disc. When the tubes attached to the disc rotate at high speed, a force is generated which pushes the particles away from the center. As a result, the solid particles in the mixture in the test tubes collect at the bottom of the tubes and are thereby separated from the liquid. Chromogetography. If two or more substances are dissolved in small proportions in the same solution, these substances are separated from each other by means of chromogetography. This method is used in pharmaceutical science, factories, and scientific laboratories for detecting new ingredients and for identifying and separating components of a mixture. Procedure. Take some water in a beaker. Take a rectangular piece of a filter paper. Put one spot of blue ink on it about 2 cm away from one edge. Keep this paper upright in the water in the beaker. Place a lid on the beaker. After some time, the spot of the ink is seen to have risen and collected on a particular height on the filter paper. If there are two or more constituents of different colors in the ink, they will be seen to have risen to different heights due to their different colors and thus appear distinct from each other. This experiment can be done using a chalk stick instead of the filter paper. In this method of separation called chromogetography, two properties of substances are used. These are the solubility of the substance in the solvent that moves up and the ability of the substance to stick to the stationary filter paper. These properties are mutually opposite and are different for different substances. As a result, all the components of the mixture do not rise all the way to the upper end of the filter paper but remains behind at different heights.